Hey, welcome back. On last video, we saw how we can connect our Spring Boot application to AWS Secrets Manager in order to retrieve secrets that are stored securely, right? Even though I pointed out how to authenticate locally with AWS in general terms, I received a few questions and asks to make a specific video about how to in fact authenticate with AWS locally in details. So that's the subject of today's video. So in this video, we will see in fact how to authenticate with AWS, all the four main ways to authenticate and when you should choose each one, and which is more secure, which is less secure, and so on. So let's get started. So as usual, we have a blog post here, a written version of this video. So yeah, basically, in order to make our applications communicate with AWS, we use AWS SDKs, right? So the SDK is smart enough to try a few ways to get the authentication. So the most default way is to get directly from the environment and not expecting to have the AWS credentials on application.properties file, for example. So by doing that, the best way to achieve that is by configuring the AWS CLI, even though you are not going to use that. But the CLI provides your local environment wide way to authenticate with AWS. So to clarify what I am talking about, let me show you guys my terminal here. So here I have, for example, AWS S3 LS, which will list my S3 buckets on my account. And here it is. So basically, when we set up our credentials with AWS, we need to run AWS configure, and then we'll be prompted to provide the AWS access key ID, AWS secret access key, the default region you want to use, and the default output format. This is up to you, both region and format. I prefer JSON because it's way easier to understand, and that's it. By doing that, you make your applications, your software development lifecycle on your local machine way easier with AWS. So by doing that, again, you'll be already authenticated. You don't need to embed any credentials on your application directly, okay? So even using CLI, we have four main ways to achieve the authentication. Let's take a look here. We have IAM User long-term credentials, IAM assume roles, federated identity, the single sign-on, and instance metadata. Let's take a look closely. But before we get started on it, I need to make a call out as usual here that this video, the purpose of this video is to show you as a developer which has your own AWS account and you want to test something, you want to develop something on your own. Okay, so it's more likely testing proposals, evaluation ideas, and not for production. Okay, we will see in a second that for production, that working as professional on a company, you will get oriented by your company how to authenticate. And you need to follow their instructions about it and not what I am saying right now. Okay, so once again, just summarize the purpose of this video is for you to use your own AWS account with like no production related things, just to evaluate some ideas, to test some services and so on. Okay, that being said, we have these four. Let me go on each one. So IAM User long-term credentials. So this is the classic way to authenticate with AWS locally. I use that on my local, by the way. If you go through the documentation of AWS, this is kind of not recommended anymore. but the recommended ones are a little complex and some depends on like corporate things. Let me explain that in a second. So this one is the classic way, right? So you go to the AWS console, go to the IAM service, create a user, create a secret and an ID, and that's it. The problem with that is the keys never expire by default. You can have a key that is there for more than 1 year. So in case this key is leaked and you don't know about it, the attacker will be using your key for unlimited time, right? The best use case is for local development, testing, and so on, as I said. So, but even though if you want to use that as, again, for this proposal of testing and evaluating ideas for non-prod, I recommend you to use that because it's simple. It's really straightforward. Okay. I also advise you to follow some best practices. You should rotate your keys regularly. Never ever hard code them anywhere. Use AWS Config to store them in your local credentials file. And yeah, limit their permissions strictly by IAM policies. We will see that specific case, this number one case, in a second in details. I will get back on it in a second. Okay. Here we have a example. I will show that live in a second. So also we have IAM assume roles. This is pretty cool. You can think like assume role as you don't have access to do something, but you need to do that thing in specific, but you don't have the permission to do that, and you actually don't need to have that permission like 24 hours a day, 7 days a week. You just need that permission for 1 hour once a week or when requested. Okay, so in this case, in this scenario, we have the mechanism called assume roles. Here, when we call assume role, we actually provide some roles to the user for a short period of time. So it has a session. As you can see here, we have a session token differently from here that we only have access key ID and secret access key. So this session is short-lived, like 1 hour. And after that, your access is expired. And even though that session token is leaked, the attacker will use that only for the short period of time. In our case, 1 hour. This is cool, but it's a little more advanced. And like for local testing, it can be like annoying to, once an hour, you need to re-authenticate with AWS and so on. So that's why I suggest you to use this solution for your local and not this one. But this one is way more secure. If you want to use that, that's the good way. But again, you will get bored for needing to run this kind of command like once an hour during your development. Okay. And actually, this is pretty good for test scripts. Like you are going to run some tests, so you get some roles, use that, and then your token is disposed. Okay. And federated identities and single sign-on. Here it relies on AWS IAM Identity Center. Formerly known as AWS SSO. This is used for companies and enterprises which has, like, for example, Active Directory and so on. So companies goes and connect to Active Directories and manage the users there, and then they have like exclusive ways to authenticate. More secure, obviously, but as a single developer, you might not have this one, so doesn't matter for us, right? Last but not least, let's say you deployed your application to an EC2 or ECS instance and it's running. So how can you generate a file and store on S3? How do you get access to the S3? To do that, you might think, oh, I can like create that user for the previous, the number one suggestion, and then I can aim that it on the EC2 as an environment variable, and I will be safe. This is one way, but it's strongly not recommended. Definitely not recommended. Don't do that. That's not the right way. That there is a way easier way and a way secure way to attach IAM roles directly to the EC2 or ECS instance. So let's think, you're already running your code inside Amazon, right? So you don't need to authenticate with Amazon to do that. You can just use the role directory. So if your application wants to write a file, to upload a file to the S3, you just need to attach IAM role, which has the permission to create object on S3 bucket, and that's it. And you attach this role directly into the instance with no code change. Way easier and way secure. Okay. So that being said, we saw all the four main reasons, four main methods. So now let's take a look closer on this one. Okay, so here I have my AWS console. I am on IAM on the users tab. Here I'm going to create a user called demo. Here, provide user access to AWS Management Console, optional. And actually, we don't want that, right? You just want to check this checkbox in case your user is a like human that needs to access the AWS console, as I am doing. But that's not our case. We just want a user to represent our local machine and then access AWS directly using secret and keys, right? If you are creating programmatic access through access key or service specific credentials for AWS Code Command or Amazon key spaces, you can generate them after you create this IAM user. So that's our case. Let's move next. Permissions. About permissions, we normally don't append policies directly into the user itself. We create a user group and then we attach the policies to the user group, and the users that belongs to that group has these policies attached to them through the group. You can attach a management policy directly to a user, but it also calls you out as a best practice. We recommend attaching policies to a group instead, then add the user to the appropriate group. So let's follow this case. In this case, I have an admin which has administrator access, which is full. I don't obviously recommend you to do that at all. Again, this is just for evaluation, just for testing. But even for testing, it would be better for you to have like strict permissions, as the advice here limit their permissions strictly by IAM policies. So here you should, like in our case, I just want to retrieve secrets from AWS Secrets Manager. So I just need the policy about retrieve secret from AWS Secrets Manager, and that's it. In our case, I won't create another group. I will just use this one for example. Here you can have like tags if you want. So our user is created. We have the demo user here, but as you can see, it doesn't still have the access key ID created. We need to create that manually. So we enter on the user, goes to the security credentials tab, and then we can create access key. Use access key to send programmatic calls to AWS from AWS CLI, AWS tools for partial, AWS SDKs, or directly AWS API calls. You can have a maximum of 2 access key, active or inactive at the same time. No access keys as the best practice. Avoid using long-term credentials like access key. Instead, use tools which provide short-term credentials, which are basically these ones here, like assume roles, federated identities, and single sign-on, or even EC2. But in our case, again, just for testing, that's okay. I will also add this article from AWS on the description right down below about in details about each of the ways of authenticate. Okay, in our case, let's just generate that. Before that, if you are liking the video so far, please hit the like button, subscribe to the channel, and hit the bell icon. It will help the channel to grow, and it will help to make this video to reach people who might need that. Okay, I will create that. When we click on the create button, we are directly to this page. Here AWS asks us which type of usage we are going to use. Basically here is just to present some alternatives. Okay, so each option you select here, it will present you some alternatives, but actually they are pretty much the same. They are just like devices, and you can continue in spite of it. For now, I will use other, and here there are some best practices. Again, never store in the plain text, disable or delete access key when no longer needed, enable less privileged permissions, which is basically this, rotate access key regularly. That being said, let's move next. We can have a tag, I don't need that, and it is created. So now we have an access key, and now we have a secret access key. So here, just to prove you guys that this is working, I will copy this and I will run once again the AWS configure. I will replace by this. I will leave US if1 JSON. Let me check if it is already set. As you guys can see, the end 5i. The next one, it ends with GQ, which is great. So let's see if it's still working, and it's still working. So by doing that, our application, when we run locally, it's already ready to authenticate with AWS with no extra code needed, with no extra property to set, with no extra environment variable to set. So we are all good. Okay, so that's all for today's video. I really hope you enjoy it as much as I did. Hit the like button, subscribe to the channel, hit that bell icon, and see you on the next week's video. Bye bye.